I did a split.
Welcome to lesson 10.6, the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. We find our b values, a values, and c values by looking at our quadratic equation in standard form with the coefficient of x squared being a, the coefficient of x being b, and the constant c. Remember, with all quadratic equations, when using the quadratic formula, the equation has to equal 0. Let's look at the first example. We have x squared plus 2 equals negative 3x. So the first step is going to be to add 3x to both sides so that we get x squared plus 3x plus 2 equals 0. Now that we have our quadratic equation in standard form, we can use our formula, negative b plus or minus the square root of b squared minus 4ac over 2a, in order to solve for x. We are going to get two values for x. Pen will work. We're going to get two values for x. And we have negative b, which is negative 3, plus or minus the square root of b squared is going to be 3 squared, which is 9, minus 4 times a, which is 1, and times c, which is 2. That is all over 2 times 1, which is 2. So we have negative 3 plus or minus 9 minus 4 times 1 times 2 is 8, so we get the plus or minus the square root of 1 over 2. So now we can break this into two parts. Negative 3 plus the square root of 1 over 2 is going to give us negative 2 over 2, which gives us negative 1. And then negative 3 minus 1 is negative 4 over 2, which we get negative 2. So though x equals negative 1 or negative 2. Obviously, this might not be the most efficient method of solving the quadratic equation, but it does work, and it will work for all quadratic equations. Think about what happens if inside our radical here is a negative value, or if it's 0. What kind of solution are we going to get? Go ahead and try the next two quick checks, and check your work when you're ready. Quick check 1, the solutions are 4 and negative 2. Quick check B, 13 and negative 9. Moving on to a word problem.
Yeah!
A child throws a ball upward with an initial upward velocity of 15 feet per second from a height of 2 feet. If no one catches the ball, after how many seconds will it land? Use the vertical motion formula, h equals negative 16 t squared plus vt plus c, where h is 0. Initial velocity is v, and c is the starting height, and t is time to land. Round to the nearest hundredth of a second. So we have our vertical motion formula. We plug in 15 for the velocity and 2 for c, which is our starting height, and 0 for when the ball is going to land. We then use our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So we plug in our negative 15 plus or minus the square root of b squared, which is going to be 15 squared, which is 225, minus 4 times negative 16 times 2, and that is all over 2 times negative 16. So using the quadratic formula, we have negative 15 plus or minus the square root of 353 all over negative 32. So using the positive root, we take negative 15 plus 18.79 and divide it by negative 32, and we get negative 0.12. Or if we use the negative root, we get negative 15 minus 18.79 all over negative 32, and we get 1.06. That tells us that because this is a real-world situation, at about 1 second, the ball will hit the ground. Looking at example 3, look at the 4 quadratic equations. What method would be best for each one? justify your reasoning. There really isn't a right or wrong answer here. There are better methods and more efficient methods. If you look at the first one here, I would probably say quadratic formula is going to work well in this situation just because we have, we can't take out a greatest common factor, and factoring it might pose a little bit of difficulty. With B is a perfect square. You should recognize that. So we can factor that into 5x minus 13 and 5x plus 13 and solve for each. You could also use square roots here. Remember, you'd have to isolate the 25x squared equals 169 and then divide by 25 and take the square root of the numerator and the denominator. In C, factoring is obviously the most efficient here. X minus 3 times x plus 1, solve for x. In D is not factorable, so in this case I would definitely recommend either quadratic formula or completing the square. Again, there's no right or wrong answer, but just by looking at the equations, you can determine which would be the most efficient method.